Hello everyone, this is Hacken. Today I'm going to go through basics of Grasshopper by talking about one of my newly printed model that I call Vase. Grasshopper, as you know, is quite a powerful plugin for Rhino, and it allows you to create as many and as crazy models as you can. To make that happen, I would say, is to develop a strong logic support. So today I'm gonna go. Let us analyze the vase first, and then we will see how it happens in Grasshopper to give you the basic idea of how Grasshopper works. Before we start, the interesting thing about this model is that the whole vase is totally created by Grasshopper Logic Web, zero input from Rhino. So don't try to do it in Rhino, because I believe it is quite a good chance for Grasshopper beginners to play with Grasshopper and have some fun. So for the model here, let's see, we notice that how the logic goes is the model consists of two parts. We have the main body and we have the surface. So for the body, it's easy to tell that we can have this body from an extrusion if we create a simple basic curve and extrude it. That's it. And the next step is transformation, because as we see near the top, the top is a triangle, a curved triangle, and the bottom is a circle. So we need transformation. And third, the model actually it is twisted, so we need rotation. And if you're careful enough, you can notice that the bottom is bigger and wider, while the top is a little slimmer. So we need to scale the model ununiformly. With this body done, we go to the surface. Of course, the first step is create a rectangular area of the perforation, and we need to make changes to it. You see near the top, as it gets closer to the top, the more perforations we see, and for the bottom, you see the very limited holes on it. And next one, if you're careful, you will notice that the sizes of the holes are all different. So there must be a pattern behind. And with all this being done, we can flow the rectangular area of the perforations onto the body, and the model is completed. And okay, today I'm gonna go through the body, and with these logics steps in mind, let's go to Grasshopper now and see how it happens step by step. Okay. Oh, sorry. It's another one. Let's make a new file. So as I said, the first step is the extrusion. But we do not really do extrusion in Grasshopper. What we do is to give a basic curve, and we move it vertically to different levels, and we loft them. So, what is the basic geometry? I believe you have already know the answer. We need a triangle. We go to polygon and give the number of size 3. Okay, here we go. See, and here's another parameter here. Let's say it's the radius. Let's give the radius at 3.0. Of course, we can change it for future use. Okay, just put it here now. So we have the basic geometry. Next step is to move it to different levels so that we can loft them. Move here, and to make it move we need a vector That is, for the vertical move, we need to give it vector at z-axis. Right now, I will need to decide how tall my model should need to be. I just say 9 inches at this moment, because it's another parameter. I give it a demand, but at this moment, I just make it 9 inches tall. And we need a sequence. We need to move the basic geometry to different levels. So we just create the height, the series height for them. Sequence with starting number as 0, and steps, as we see, means the number of reference planes, reference curves. I say 40. So this number is not a parameter here. It's a constant number. I need to I need to make it clear, because for this number you will see later. But say for the steps, you don't want to make it too many, like 400. I believe, because you make the calculation so complicated and your computer would die for it. And 40 is what I really take. If it's too few, it's not a problem. We see. And sorry, yeah, we divide the total height by the number of reference planes, give it to the step size. Let's see what happens here. Input to vector and geometry. Here we go. But here's a trick here. Sorry. If we go check the sequence, the series, let's see, we have 40 items, with the last one starting at 8.775. It's not 9 inches tall. The problem, yeah, it's here. If we divide the total 9 inches by 40 numbers, each step is 9 over 40. But now we have only 39 improvements. I mean, yeah. What we need to do is divide minus 1. Here we go. 9 inches tall is right. So this is the first step. Down. Yeah. Next is transformation. Let's go. Let's take a look at the model again. The top is a triangle. The bottom is a circle. So it makes us think fit it. Let's see how it works here. Inputs the geometry we already have. Give it, say, 0.5 as a radius. Let's see what happens. See, all the vertices become part of the curves. It's filleted. And if we change the value of the radius, see how it works? So if you are familiar with the geometry stuff enough, you will see in an equilateral triangle, if we call this R2, and the regional radius is R1, if R2 equals half of R1, you just make the equilateral triangle a circle. right? So it gives us a hint here. And what we need to do right now is to create another series, a continuous change for the Philly values. We can again go to the sequence, create another sequence, but this time let's do it another way. We use demand. First, we create a demand for the Philly values with the starting value as the top we need, and the ending value as half of the original radius input to the demand, and we need to divide it. Here's another tricky part. We have a demand, say you want to divide a segment of line into several parts. If we divide it by 40, let's check it. It gives us 41 values because it really started from number 0 and ends at number 40, so it really gives us 40. So to have 40 points, we need to divide the demand by 39 parts, and we input to R2 or the Philly value. Yeah, here we go. It seems that it's reversed, but we can go and reverse it back. That's it. So with this being done, next step, let's check our logic map, is rotation. As you see, it's twisted. So for rotation, let's go to rotation first. Look at the inputs. We need the basic geometry. This is what we have here. And we need rotation angle in radians. And we need rotation plane. So how do we find all the stuff? We'll just do it one by one. If you go to surface and the area stuff, input is a basic geometry and it gives you two outputs. One is the area, the other is the center. Like this. Well, here we notice that it's not the center, the rotation center is not the center of the geometry. Yeah, for this part, sorry. Let's go back, check the basic geometry. We have the center here. What we want to do is give it a vector and a value to move the center to move the rotation center from the center of the geometry. So here we have a point. We need another one. Again, we go move. And if we go to deconstruct, construct grep. This is just like a tool to analyze a basic geometry. It inputs geometry, it gives you face, edges, and vertices. And we have listed 3 vertices here, and we just pick any one of them. Say here's number. Okay, look, here's the green point, and we go to vector to create another vector from 2 points. Let's see what we need here. A is a base point, the center of the geometry. B, the tip point. So this is a vector we have created right now. But a vector is just a direction. What we need is the magnitude, how long it moves. So we go to amplitude, insert inputs vector, give it another value, say 1.0, sorry, 0.09, just 2.8. Sorry, I just give it to make it more visible. This is another parameter here. If you see, let's close part of it. How it moves. Oh, it's not big enough. Sorry. Let's give it 5. Yeah, this is how it works. So with the new basic geometry we move this geometry the same way we did for the basic geometry. I mean the basic triangle. Just copy it from above. Yeah. So this is the rotation, the new rotation center. Here we go. And let's see how it works. Right. Now what we need is the angle. The angle is kind of tricky because if you are careful enough, you will notice as it gets closer to the top, the model is twisted faster and faster. So it's not a uniform sequence. There are several different ways to do it. You can create your own method. Right now, I just introduced one of the simplest you will know very quickly. I just create another sequence. Say I want the top one to rotate by 180 degrees, and I take it to the power of 1/2. And how many sequences? Yeah. Again, we need 40 items, 40 steps. but step size should be the biggest number divided by 39. Yeah. So with this done, let's check. Oh, not now. So, and we take it to the power of 2. Yeah, with the last one as 180 degrees, and you can see how it goes faster and faster. And as we read from the notice, rotation angle in radians, so we need to convert it to radians from degrees. Here we go. Now we kind of see the shape already, and the last step is to scale. To scale this, we go to scale, and let's check. So first is, again, the first input is the basic geometry, and we need a scale, center of scaling. We take the same strategy, find the center, and now what we need is a scaling factor. Again, just as we did before already, within another sequence. And again, you have millions of ways to do this, but now I introduce, let's do it in another way other than we did before. Let's go to Graph Mapper. Input any of the sequence we have already, and right click, check the graph types and choose whatever you would like. Right here, just choose sine input. Okay. Okay, it becomes red. Let's go read the note. Cannot scale with factor 0. Oh yeah, it hits factor 0. So if we change it a little bit, yeah, it works. It's working now. And if we look at the model, but if you go to change, say I give it 10, how it works. Okay, here we go. It's not enough. I'll give it a say 15. Okay, it looks a little better. Like that. You can play with this for fun yourself, or you can choose other ways. You can also go to math and do an expression, type in a formula you like to make it happen, or you can just change the graph types to whatever you like. Spend some time with this, you will have a good time with it. Right now I do not spend more time on this. Let's just go directly to loft. This is what we have. Yeah, with this till now we already have the main body of the vase. And next time I'm gonna go over the surface, the perforations. And thanks for watching.